Hey, uh, just want to give you a quick update on the project that I'm trying to do. In this project, we were trying to predict the electrical energy output of the combined cycle power plant. We know that there are certain parameters like the temperature, the ambient pressure, relative humidity, exhaust vacuum, all which plays sway. And based upon these, the net hourly electrical energy output is what we are trying to predict. So to kind of solve this problem, what I've done is I've taken the data which has been given to me, and that particular data has been analyzed. The first work that I started doing was saw that all the information, the raw data that I got was within the range. So if you can see this here, they were all they were all up within the ranges that we had for for the data. So this is the first validation of the data. That's the first step that I wanted to do. Make sure that there are same amount of data. I know that there were about 9,500 records which were there. Then I just kind of did a high level approach documentation of what I wanted to do. The approach that I'm taking is I'm trying to divide the entire data into three folds. The first fold, which I've taken about 70% of the data, which is there, and I just split it out and kept it for the learning. And the 20% of the data after that is been kept aside for verification during the modeling, and then the last 10% is for testing it post it has been implemented. So that's how I split my 100% of the data. Now that being said, I took the first approach of started thinking like what other things that I can do. I had to select my model. If at all it was going to be some amount of classifying information into different types, then I maybe I would have gone with a classification model. But here, since we're trying to predict an output and derivative and number, the best model that I can think through was the linear regression model. Again, try to keep it very simple because it is easy to understand, easy to implement, and relatively, if you start looking at the problem, the factors that has been put forth looks to be directly implicated to have a have a an correlation with the output. So I started adopting to the linear regression model. So predominantly looking into that, I started the next step, which is nothing but to break the data. So this is the data split I did. I split the data into to multiple folds. The first one being that I came to the bottom, had 6,698 records, which is 70% of the record to be put forth for the learning. Then the next 10%, next 20% of the data, which is about 165 odd records for the verification part, and then the rest about 900 record for validation. And now, after doing that, the first model that I wanted to kind of adopt was assuming that all these three factors are playing a part. So I started kind of using the regression. The way I did that was I went back to I had to just I'm using Excel to do my work. So I went back and ensured that the formulas which is required is being adopted. So I've enabled the data analysis tools that is required for me to get this things working for me. So I just went back and started going to the add-ins and basically went ahead and analyzed. Started getting the data analysis and enabled for me. And then I did a data analysis. What I did was I used the regression model and outputted the model. The best part and the good confidence I got was the R function, the multiple R function is showcasing about 0.96%, which predominantly gives me a very good. It is less than a percent, which is very 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 positive for me. Now, utilizing this particular information, I started building my model formula. So I started using the coefficients which has been kind of showcased out for both the temperature, exhaust, ambient pressure, and relative humidity, and started multiplying these coefficients with the temperature, exhaust vacuum volume, and relative humidity, and then just added that out with the intercept here, which was there, and then got my formula. Uh, I mean, arrived at. Now I already had these test data with me, so using that I just saw how my model was working, and predominantly it showed very good positive results. And if you really see, there's a very good match for almost all of the numbers. So if I take a relative average, an average of all the output that I've taken, I think it's less than 0.14 times. Just a variance of that. So this gave me a good kind of an confidence that this was working well. Now I started going back and used the test data as well, and started seeing again, did the same part, and again with the test data as well, this was very positive, and the numbers look good. So this was a very strong model. Just to kind of try out if it is looking good, I tried to see if at all do we require to have this RH and AP, whether they really make a say. So I got rid of both of them, and then saw a model which is just using temperature and exhaust vacuum. I built it, and that also had a very positive number, 0.964 when compared to about 0.9646. So literally not much of a change. So this model with the less number of parameters is still working well, and it was able to give me the a better prediction. So this is the prediction model that I've kept forth for now, assuming that a factor of these is something which is going to give us the prediction that is required, and that's working well. Thank you for watching, and hope this was a pretty good understanding that I got to know how to really use the data, how to use a part of the data to do the validation, part of the data to do the verification later, using and understanding which model to pick up. And feels good to see that the prediction that we are trying to make is relatively matching to how the output is coming in. Thanks for watching. See you. Bye bye.